Good evening all, this is my first Facebook Live, so you have to bear with me because I'm not used to all these setups and all everything else. This is just a few questions on the over Unity motor. I'm getting a lot of feedback on the coils, the shaft. I have actually made some notes tonight as well. So we're going to talk about just a few things. First things first, perpetual motion. Okay, now perpetual motion, the word in itself, perpetual motion means you spin something up, and if you put your finger or whatever you spin up and stop it, it stops. That's perpetual motion, right? The word has been bounced around many years. Okay, the Patent Office likes that word perpetual motion. Most people who go to patent advice, inventions come up with the word perpetual motion, and it gets thrown out instantly. Okay, so what I'm going to do, hopefully, I have no problems with this tablet tonight. I'm going to place that there. I brought something down tonight. Now, I've had this in my possession for a long time. Most kids know what these are. And what I'm going to do, I'm going to spin this up and I'm going to put it on the floor, just to make sure you're aware of what this is. Now that's perpetual motion. Now if I kick that, it'll keep going. Yeah? If I stop that, that's perpetual motion. Okay? And eventually it'll die down. Sorry, this is my old phone ringing. But there you go. That is perpetual motion in itself. Okay? So that's what we're talking about. We're talking about the perpetual motion it's been bandied around a lot. So we're going to jump from perpetual motion. So the over Unity motor, if it's classed as perpetual motion, I should be able to grab that shaft and stop it instantly. And it shouldn't hurt me, technically, theoretically. You see me do that test on 2 videos. There's no way I'm grabbing that shaft. So this over Unity motor, in my eyes, is not perpetual motion. So the next question will be, if it's not perpetual motion, I should be able to put anything on that shaft. Technically, theoretically. Now, hold your thoughts on that. I'm going to show you something. This here is a DC motor from a... Hello. Yes, I'm live.
Turn your phone on silence because it might mute your video because of sound in the
background.
Oh,
okay.
Yeah, keep it on silent. I was going to do it sneakily for you.
That's alright. These Facebook Lives never go according to plan.
Yeah, because copyright sounds and stuff, it'll mute your video.
Right, okay. DC motor. So that was the missus. This is the first Facebook Live. This is a DC motor from a... what's it from? Running machine. Right? Now, it's quite heavy. Now, if I was to try and stick that on the shaft of my over Unity motor, that's a lot of weight there. Okay? All DC motor, AC, DC, they're all heavy. Okay? Now, if I was to, a friend of mine, good friend, Grant, asked me if I could put this machine sideways. Yes, I can. Okay? Could I stick this at the side of it? Possibly. Do I want to do that? Not really. Okay? Because every shaft on an AC and DC motor is quite stiff. Yeah? Because this has got brushes in it as well. So if it wasn't brushes, it'd still be stiff, which means I'll have to take out all the grease from the bearings, and which is another one not many people understand. So someone said to me in the past, how come you took all your grease out your bearings? You don't need grease in your bearings. Why not? Because you don't. And then obviously it'll heat up. So we done that test, and it didn't heat up, it got cooler. Yeah? The bearings don't implode or explode, they don't heat up, okay? Especially on these motors, because you're drawing energy from the vacuum, which is cold electricity. Now, if we had a way of looking at the machine, not through our eyes, what you technically would see was like a vortex. Like when you stir your cup of tea, that's what you'd see, okay? It's cold. So we done a test with a heat gun, and it got cooler. The coils were warm as normal, because they're charged on the back end. But the bearings were cold, even to the touch, as if they were ice cubes. Okay, so my opinion on bearings, depending what you're doing with bearings, I always brand new bearings. I take them down to the kitchen, put ferroliquid in them, clean all the grease out of them, and run my machines with them. You get more of a all right. So all questions regarding anything I can put onto the shaft, it probably would. Do I want to bog the motor down by doing that? Probably not. And when you do that, it's going to draw more power because it's like the resistance when it goes into the battery. Yeah. So like I said on the previous videos, none of my videos are pre-planned. So it's literally got to come off the brain and away we go. So that's quite heavy. That's probably, should actually say how heavy it is on it actually. No, it don't. But this is for a 4,800 RPM, 100 volt DC max power output. Okay. Yeah. I would do a video if people want to see me do this. Personally, it might work. I can't see it working personally. All right. Now, I mentioned Joseph Newman on one of my videos. One of my YouTube videos. Now, Joseph Newman, very, very clever man. Yeah. Spent thousands of pounds in court trying to get his device through court. Now, he was the only one that's come up with. I've got to go by my notes, people. Just bear with me for a minute. Right, he's the only one that's come up with atoms precess at right angles. So, for example, if I was to get a piece of copper straight and run a magnet past it this way, all the atoms in that copper are all over the place. As soon as the magnet passes, they all align and shoot right angles, which means they shoot up the copper. Okay? So, the generator that sits on this over unity motor is basically, it's going to be not a block, but what's going to happen is it will sit straight into the centre and have north and south magnets all around, with all the three-phase generator all around it. Okay? Which is, hold your horses and I'll show you. Which is the baby one that I showed you in previous videos. Which is this, alright? Which is all handmade by me and wired by me. There is bits of it missing because I was mucking about, okay? But this is the three-phase. Obviously it's incomplete now because I've been taking stuff off of it, okay? So it's basically like a clock. You take all the notches out. You didn't really want to do this because this gets confusing for people. But most of the point I'm trying to make here is, when you stick a magnet in the middle of this, the magnet precesses the atoms at right angles, okay? So as long as you've got a very, very powerful magnet in here, this will produce energy. This is your generator, but it's only a baby one, okay? So, on that note, I won't want to put a DC or AC motor on the shaft. Yes, the shaft is powerful enough to do what he's got to do, but you've got to find a way to stick anything on top of that shaft. And that is only a 12mm shaft, okay? Yes, it can be upscaled. Yes, it probably can be upscaled, turned to the side, and there's lots of further experiments that needs to take place with this machine, okay? Now, for example, I also didn't want to mention on tonight with, when I said to you about the one-to-one battery system, because the one-to-one battery system, I want you to get the concept of powering and charging. Once you've got the idea and you've built it and you're powering and charging, the next circuit would have been 2 batteries and 2 batteries. Even though I'm using a 2 battery system, what I'm trying to explain to people is, right, how you doing, mate? What I'm trying to explain to people is, once you use one battery to power the system, and the backhand charges one battery, you use another battery to power the system, and charges the back end of the battery. Now what we're going to do here is we use battery A to power battery B, and then battery C to power battery D. Yeah, it gets very confusing, but this will be on the next circuit, and I'm not expecting anyone to understand. I'm getting a lot of confusion on the first circuit, so this is why I want to go very slowly with it. Right, so perpetual motion we've sorted out, torque on the shaft we've sorted out, magnet spacing. Now magnet spacing, I've actually pre-prepped myself for this one. This is for the guys and girls who asked. So hold your horses, because I've purposely prepped it tonight. I've just pulled mine right out of its machine. Alright? Now, the last video, you heard me experimenting with round magnets and round coils. Today I've been experimenting with rectangle magnets and round coils. And for my by surprise, the rectangle magnets with the round coils work extremely well, right? So, even though I've told you to do rectangle magnets with rectangle coils, just keep to that because it's a learning curve. You're not wasting the copper, because once you put the copper on the spool, you can re-spool it onto another spool, and then put it into round. So don't ever think you've wasted your money, because you haven't. But the answer to the question, to magnet spacing, yes, the magnet spacing is 1.5 inches from magnet to magnet, okay? And you have to, get hard on this camera, it's too much writing, I'm not used to the writing down the side of this, right? So you have to, right, let's get this so it's in camera shot, and I drop it, it weighs a ton. If a coil's here, and the coil's here, they've got to be in line with each other. They don't have to be in line with each other. They don't have to be in line with each other at all. You can have it, for example, one coil here, one where my hand is. That's normal, because that'll be an instant spacing when it powers up. You can have one coil here and one coil here. Now on this, I have 16 magnets, which is off balanced, because this is the only wheel I've got hold of at the time. So I put on 16 magnets. So then obviously I can't mirror it from 9 to 3 on the clock, if you like. So I had to take the coil just off the 3 o'clock mark. But it still does the same principle. You can have the coils, one here, you can have one here, as long as it's push and pull. Okay? Ideally you want it 3 and 9. And obviously trigger coil up here. That's what you want to aim for, which is on the circuit. And put this back to where it's ton. Right, that's that. So, magnet spacing tree. Right, so I've explained that. Battery switching. Right. I've never looked into. I have and I haven't. The idea of this over unity motor is to make it as bare basic as possible. Yeah, you do not want to put any electrical devices on it. Those stupid, I can't even pronounce the name, Arduino kits, or whatever you want to call it. They automatically switch from A to B battery for you, okay? Now I do speak to a bloke at work, and he's aware that this stuff does exist. His only problem is, he wants to power it up and walk away. Which I agree with him, because you don't want to be coming down and go, how much battery we've got left on before I have to switch over. You've got to remember, no one knows these really exist. Only a few people in many countries, right? Or quite a few people in many countries, but people are still tinkering around. If we start putting electrical components on it and circuits here, relays there, people look at it and go, I ain't going to bother that, it's too much hard work for me. So, what else we got on here? So, the coil winding and the ohms, right? Right, so the ohms. I told you to start with 0.6 ohms. The reason why I told you to start with 0.6 ohms is because as soon as you power up, it will only take a little bit of the primary power into the motor. The less ohms, the less power you use. The more ohms you use, the more power you use. So for example, hold your horses, on one of my coils, which is I've showed in the last video, which was 2.4 ohms, that's a fair bit of copper there, right? Now if I was to use these coils on a 1-to-1 battery system or a 2-to-2 battery system, that will take a lot of my juice from the primary battery, right? Regardless how many transistors you're running, it all depends on the ohms of your coils, okay? It ain't the wraps, okay? People are getting too confused with how many wraps is it, okay? It's ohms, so the less ohms, the less power it uses, okay? Even though you still got to pay for the switch, it's a lot of energy in the coil, okay? Because it's all connected. So, on that, and coil winding. Now there's a lot of people, to be fair, I thought people might have understood most of this, but I'm going to have to grab my one down off the, the shelf up there. It is homemade, it is bare basic, because you don't want to confuse things here, don't want to confuse things at all. So I'll grab that down, you probably won't understand it, but give me a second. Right. This, if you can see, it is a homemade jig winder, the bare basic you can get. So here is where I put my copper, yeah? Now it's just on a shaft. I can stick a nut, if I turn it round this side, bare basic. That is it, this is where I'll be winding my coils, okay? And if you want something really fancy, you need to have a clock, okay? At the side, because I use this for the wind turbine coils. But I will upload some pictures of these because I know it's going to be confusing for people to see on the camera. But yeah, other than that, I don't really know really what to really talk about. Really, these are some of the stuff I got in. Perpetual motion torque, magnet spacing. Yeah, so the magnet spacing, you really want to get it. So from 3 o'clock and 9 o'clock, you want the north and the south. Yeah, so push and pull, push and pull. Anything else? What else anyone's saying there? Come off of that. Fletcher Baker. Right, okay. What else? So someone did ask me about the ohms and how do you get the ohms. Right. The only way I can explain this, because it's going to be a little difficult, because it's quite difficult to have the tablet going and for you to see what I'm doing. So basically, once you wrap what you've wrapped, you ain't going to determine how much ohms is on your coil, right? There is actually a coil where you might have seen it, you might not. Ah, you did there. Right. So you see on this trigger run coil I made, right? If you notice very carefully, I put a black line around it, and obviously I know how many ohms are on this. Okay, so if anything was to go wrong, I don't have to worry about rewiring and checking the ohms because I've marked it with a permanent marker. Okay, like I say, these are all. This is experimenting. All of it. It's experimenting. So yeah, someone said to me about the glues. I'll get them again. Hang on. Because I was running the machine last night, it's quite noisy in here. Right. So, the magnet motor you just seen of mine, that I showed you with all the magnets, the only thing that's holding up the magnets is this stuff. Okay? This is the only stuff that's holding it up. I have used the other stuff, that's how I know it's absolutely deadly. This stuff, you can power it up and it will go fast, they will not come on. Once they set, they will set. This stuff is unforgiving. It's A and B, okay? Loctite. It dries like cement. Like I say, if you're going to use this, once you place a magnet and it's in the wrong place, game over, okay? You'll have to stick a flathead screwdriver behind it, tap it off, the magnet will go into bits, but at least you salvage the rest of the wheel. So, what else to think? I don't want to rush too much. Batteries. Now, if you're going to use, once you use your batteries and you're up and running, what you want to try and do is you want to try and match your batteries. Don't do what I've done, okay? Don't forget, I've been experimenting for a long, long time. So, if you're going to, for example, hang on a minute. We've got one battery there. Right. I've got two batteries here. These are way done. Little battery. So this is a 12 volt 7 amp hour battery. Now for example, I wouldn't use that as my power source and this to charge on the back end. This is a 12 volt 17 amp hour. Okay? Yes, it will probably do it, and yes it does do it because I've done it, but the problem is with these two, you need to match your batteries. So your primary battery and your charge battery have to be the same. Okay, even though the 12 volts still, they have to be the same. Right, you can also as well, which I've also experimented. This is why I didn't want to do a Facebook Live, because I want to try and keep it so I can subtitle it within Facebook. You can run these in a parallel. You can run it in parallel, charge it on parallel. You can run this in series and charge it on series. Now personally I run mine in series and charge it on series. I've also tried it on, run it on parallel, charge in series, and the other way around. What I've noticed with the parallel is you lose power before it gets to the back end because it takes a little bit longer to charge. So if you need to know all this, you need to look up the wind turbines, how they charge their batteries in series and parallel, and they'll tell you, okay? The stud bars. So now what I'm going to do, I don't know if I can turn this camera around. No, I can't. So there's mine sitting on the floor. Okay, the coil's a little bit different because they're round coils I've been mucking about. Okay, it is basically 4 stud bars, bit of perspex. Forget the white trim because that white trim was for hiding wires for future people that are supposed to come round. Okay, and then I've decided just to let all the wires out. But that is it. This is the jig. Okay, And let's bring you back round. Someone asked me about bearings. I've got shit everywhere in this shit. Where are the bearings? Right. Right, here we go. Don't forget, so not a lot of money's gone into this because this is a toy, okay? I want people to realise this is a toy. This will be upscale, but this is a toy. So I'm going to bring it down a little bit more. There you go. Right, that's better. This is a toy. So this is a 2-bolt flange bearing, alright? They are cheap. I think they were something like £6 for 2, alright? But they're good if you treat them right, alright? Take the grease out of them, install them and play with them. Right, the other thing, these are little things I forget since I do all these videos. So give me a second, I'm going to grab you something and show you. Once you put, now, magnet stator goes onto the bearing. This is why I need people to realise this straight away. It's very important to remember this, okay? Once you build this and this goes into the flange bearing, alright, and it sits on there, what you really want to get hold of, I forgot what these are called, cup links. I'm going to get a couple of these, okay? For the simple fact is, what you want to do, you want this cup link to sit on that bearing, just like that. And I'll explain to you why. Because once it goes in there, and it goes onto the bearing, see the spacing we've got now? Okay? And there we go. So these are little things even I forgot to mention. Okay? And that's it. Right, so if I took that all off, take that down. This bit in the middle, you might be questioning why I've got that bit in the middle. This is homemade by me, apart from the top end. So it's drilled right through the centre, attached by bolts, nutted on the other side. Okay? So I can grab this, not grab the shaft, I can put something on this shaft that's going to go with the wheel. Okay? Because this is where your generator's going to sit. Now I can show you now, because it'll sit like that. Okay? That's how it's going to sit. Don't forget this is incomplete, I've been ripping this copper off this. Okay? That's how it will sit. It won't sit on the wheel obviously. But there'll be magnets on this shaft. So imagine a block of wood and all 4 corners of the block of wood will be magnets, north, south, north, south. Remember, atoms precess at right angles. So once the magnet passes that copper at right angles, you will generate voltage. Okay? No different from wind turbine. Now, on the circuit, people will actually, I've put on their actual flex wind turbine. Yeah? That was one of my first ever circuits I drew up. So the first circuit, you probably noticed on one of the videos, actually disclosure circuit 1 of 3, you look at the circuit, there's north and south magnets from back to front. Because that was the wrong circuit I pulled out of my drawer. But I've corrected that and uploaded the correct circuit, hence I've done a video on one of them as well. So I forgot to even put a comment on there, don't use that circuit that I showed you on the video on, it's got 200 views on it now at the moment. Use the diagram I uploaded, okay? So that's that. But that is what's going to happen. But obviously, I'll explain how to do the 3-phase. And to be fair, I've got to chase down, where's the fucking ton? Hold on, papes. Right. So basically, because people are going to want to know about this, I know they are, I'm going to get a load of messages. Right. So when let's see if I've got any markings I can show you. Right, there is markings, but I'm going to just show you differently. Right, so we've got 1 hole, 2 hole, 3 hole. Right, so we've got 1 dash, 2 dash, 3 dash. So mark them up 1, 2, 3. So when we go on to 1, what we do, we go clockwise, 50, maybe 100 turns. Alright, bear in mind, the thinner the gauge, the more voltage you get. The thicker the gauge, the more current you get. You want an equal balance. But I'll go into that in a bit later videos. Hang on. So, clockwise, 50 turns, 100 turns, every turns you want, okay, because it's going to be upscaled, right? And then once you've done your 50 turns, you want to go anti-clockwise on the next one. So you want to miss 2 and go anti-clockwise, miss 2, clockwise, miss 2, anti-clockwise. That's going to be a little bit difficult for people to understand, but that is the sole purpose of it, as you can see. It's a shame I've destroyed it really, because you should be able to see how it goes. So I think, yeah, this one, it would have got over there and back here. That would have been 1 phase, 2 phase, yeah, and then it would have been 3 phase, yeah. And it did use this, okay, it did work as well, very, very well. So, what else? Transistors, right, you definitely need to get hold of this and this. Right, this is the other thing I also forgot to mention, because I was so bent on trying to get it out to you guys. It's the little things I was expecting. Well, I've had a few inboxes, quite a few people inbox me. But rather you waste your money, this is why I've had to make little notes for myself to remind myself to let you guys know. Right? When you buy your transistors, it's very, very, very important that you buy thermal paste. Okay? So you need to thermal paste up all your transistors. If you do not put the thermal paste on and you put them on this block, they will burn out within 10 seconds. Mark my words, I've done it. Okay? And some of these transistors are not cheap, and some of these transistors are coming all the way from the other side of the bloody world, and you have to wait 3-4 weeks for. Okay? Ask my missus as soon as I come to work, my transistors here? No? Oh, fuck's sake. Alright, so it can be quite annoying. So you need to paste up your transistors, and you need to get hold of an Ali block. Now, don't forget, I ain't bought none of this. This is all salvage shit, okay? Someone else's rubbish is someone else's gold, remember that, okay? And I'm from Tilbury, and that's word of gold. So, this is just from a PC. I've actually got, this is actually a 2-part. As you can see, I've cut it clean down the middle, yeah? It is to allow the heat to go straight through the alley, so these don't overheat, and you've got extra additive protection with the paste, okay? And for the ones that haven't seen the video, on the other videos, all this is they're looped together, okay? So we've got base, this is for the blue, the emitters are obviously the earth wire, and the collectors are obviously the brown wire. Remember, this is not bought cable either, so just for that note, I'll show you exactly what it's from. Once again, the wire that I've used is from a Hoover. So inside the Hoover you've got a brown and blue wire. That's all you need. And on that note, the same wire is here. Brown and blue wire. Let's just chuck this over there. Alright, you also need to get yourself some crocodile clips. You can get 150 of them, $6.99, okay? Yeah, you definitely, these are a must, right? Now, also, if you're mucking about with big car batteries, these are not going to cut it. So what we would do on that note, should have prepped myself on this. You would stick the crocodile clip on the terminal and use a big crocodile clip, disconnect it, okay? If you want to go out and buy these extra duper super duper things where you stick on the car battery, it's got a little niche at the side and you go clonk and crack on. Alright, but the idea of this is to cost you next to nothing. The only thing you really need to pay out for, realistically, will be magnet wire and magnets. That's it. The studding, pennies, right, the Perspex. Someone asked me about the Perspex. Shout out to Paul. It is expensive stuff. I didn't buy it, okay? I was given it, and that is 1 inch thick, okay? But don't forget, if you go and buy, got no small stuff here, I have, but it's too big to come over. I've got 1/2 inch Perspex, even a 1/4 inch Perspex. Even if you get a couple of them sheets, clump them together, once they're studied up, top and bottom, they're not going to move, alright? You can use wood as the main structure, okay? Yes, it does, it's got its own little thing going on, it swells, dries out, moves about. You've got to remember, you just want to try and get the basics out of the way, so at least you know the basic setup, okay? Someone also said the circuit itself. Right, let's see if I can get it on my phone for you. So basically, the circuit itself there's 2 points on the circuit that's very, very important. Okay? So let me do it. Someone alive, can't go on Facebook. Right, so basically on the 2 parts of the circuit that fly off either end. Okay? So you've got one going to the primary, one going to the charge battery. They're your 2 open source points. Okay? Take them points away, you'll have a normal conventional motor that will kill the dipole to a certain degree. It probably won't straight away, but it will give you aggro. Remember as well, back EMF is not as great, is not great, I should say, with the power you're putting in. So someone said to me, well, that's back EMF generating that. No, it's not. Okay, back EMF is always half or even quarter of what you're sticking in. So if you're sticking in, say for example, 60 volts, the back EMF will be 10 volts. Okay, because you've got to remember what you put into a coil. So you've got to remember this now. So this is really gets a bit confusing. When you power a coil, it's like a spring. So you're powering it, goes ooh, and then what happens is when you turn it off, it releases. Okay, and that's back EMF. So yes, anything on the comments? Froggy, Tony Davis, my mother-in-law, how you doing, Shaz, Eric, Fletcher. So yeah, there you go. There's nothing else really I need to really say. Actually, someone asked me, can I stick a car alternator on the shaft? No, it's too heavy. Okay, you got to remember, a lot of the stuff, like I said to you about the DC motor on the shaft, they're too heavy. You've got to be able to fix that to the shaft. Even if you was to turn it to the side, you've still got to find a way to connect it with couplings. Okay, in about 6 months' time, I'm going to show you a couple of things. I'm going to show you 2 induction motors. I'm going to show you Joseph Newman's motor. Now, Joseph Newman's motor, actually, it's such a shame I destroyed that because you guys would have loved it. It powers itself in a load just like this. So you've got a load of windings of copper. Yeah, the more copper, the better. The thinner the copper, the better. And what happens is you use, I've got them right here. You use these to power the Joseph Newman motor. These are 9-volt transistor batteries. Alright? The power goes into this, will get transferred into capacitor. The capacitor will charge up, or not charge, it will run Joseph Newman's motor. And then the back EMF from his system comes back in, goes back into the plates of these transistors, and the cycle starts again. But the torque on that motor is so scary, yeah, it's unbelievable, okay? And you have a plasma arc that's coming off the manual commutator that I made. And that manual commutator I can show you, because people will ask me about that as well. So this is the manual commutator from the Joseph Newman. I'm going to take the 2 wheels off. So you've got 3 wheels, disappear the wheels, alright? And you'll have a wheel with solid brass all the way around it. That will be your positive. Same again on the other side. 3 wheels. These are the stabilising wheels. You take them stabilising wheels off, and you'll have a wheel with only a quarter. So you can understand as it goes round, on, off, on, off. And what we're doing is only on when the north magnet is facing the coil. So atoms only precess at right angles, yeah? And that's how it makes the machine run. But it makes the machine run very fast. I would say near on, for the one I had, near on 12,000 RPM. I couldn't even keep it on the floor, on the bench. I couldn't keep it down at all. It was absolutely, I put it on my kitchen. Mate, it scared the shit out of me, okay? It ran fast. But it had a neon green, bluish haze off it. It was plasma from the negative energy straight into the machine. So that's coming, but I'm still building. I'm halfway through that, and I can say to you I'm halfway through that because this is the flywheel off of it. Okay, so what I just showed you, it'll be one here, and there are a load of magnets here, and it'll be sitting inside. Okay, it's only going to be a small machine, but don't be deceived. This thing's dangerous. Okay. Remember I said on one of my videos, there's just a little shed, there's only one exit, so I need to be able to get out of that exit if something goes wrong. So, there you go. Yeah, I've got nothing else really for you. I can scale around the actual base of my machine if you guys want to. On that, I'll take it out of the way, move that out of the way. And as you can see as well, this is the perspex, the top lid. If you look, how many drill holes is in it. It's to adjust the flange bearing, okay? And yes, it is thick, okay? But don't forget, this was scrap. This is scrap. This is I was giving this. I said, oh, do you want that? He went, no, you take it. Thanks, I'll have it. All right. So if you go past people and you see a, not saying that diving skips, but ask people if you get rid of that, can I have it? Okay. But you can use wood if you just want to. You can descale it. What was it? Someone said to me as well. Trying to remember a load of things. I took a few notes, but yeah, definitely stay away from these electrical circuits. I was going to mention that quite a few times tonight. You want to make this as basic as possible. You want to make it that basic. Even the circuit diagram for this, the first circuit is so basic. A 15-year-old can build it. Okay, that's how basic I want it. I didn't want it confusing. So if you go online, a lot of people building stuff, they go, oh, this one. They make it so confusing. It's just, you look at it, you go, that's just too much aggro. Okay, that's why I hate cars. That's why I hate car mechanics, because you open the bonnet and go, yeah, I can't be doing all that. Okay, so the older car, the better they are. Okay, the newer the cars, the worse they're getting. Okay, so right, so on that, I'm going to try. You're going to watch me reassemble this, and we're going to start it. Yeah, that's how we're going to do it. So let's do this. Right, I'm going to put you on the floor. Hopefully you'll be able to see exactly what I'm doing. Good day. Right, put all these chairs out of the way. Put a little gyroscope. So that's that gyroscope I was telling you about. Okay, this is perpetual motion. Yeah, this is what the kids play with. And we have a string's gone to now, but it's here. But that was just a way of trying to show to you that perpetual motion. This is classed as a perpetual motion machine, but it's not, because once I reassemble this and start it up and let it run, once it powers itself up, it's got to gear itself up. Once it's at full power, it's at full power. So then try to touch that shaft and tell me it's perpetual motion. Not a chance on earth. All right, but it's not designed to run DC motors off of it. Okay, this is a motor that powers itself on the load, and we're going to use the shaft to generate power, just like a wind turbine, but we're using a mechanical shaft instead. Okay, and actually, I might even attempt to put this, which is basically a paddy saw blade with a lot of magnets on it that weighs a ton, on this shaft, right, to see if it slows it down. It will slow it down, but to see if it stops it. And if it doesn't stop it, then it's not perpetual motion. Alright, so we'll try that as well. Alright, let's get this all back together. Ooh. Love you. Right, if you guys want to say anything in the comments, if you're asked or anything, don't be afraid to ask. Okay? Because I've had people ask me some questions. It might be silly to you, but it's not silly to me. Alright? You've got to remember, I asked a lot of silly questions for many years all around the world. That's what I meant. Right. And these coils on this machine are not being glued down. Okay? Well, the reason why they're not being glued down is because I'm still playing around, okay? I could have fixed them in place and gone, yep, that's it, we'll leave it at that. But obviously, we are still playing. You know, mate, because obviously mine are not glued. I've got to make sure that the wheel don't hit them, okay? And also, it goes up and down. It's a bit tight, that is. Right, let's get some batteries. Right. Still alive, push date. Right, also, when you do build this, always set up your back end first. If you set this up before putting on the back end and you power it, you're going to blow everything, okay? Absolutely everything. You. What have you? Right. Always use your multimeters so you know what's going on. Especially if you're learning, because you can power these up and if the primary battery's not going down and you think you ain't got a multimeter on it and you won't know it was going down, what you'll do, it will burn out all your transistors, okay, because the energy's got nowhere to go to power up to the motor. That's that side. Right, I'm going to swap you over from it now. Take you over from here. To here. Hope it won't fall down. Right, push it. Right. And the other thing I also mentioned, because you're doing a one-to-one battery system, you can literally just start it up manually and put your power source on. You can do that, it's not a problem. Because I've got 2 batteries this side and 2 batteries that side, I did say to you, you can run as many batteries as you like, but be warned, if you punch too much into the machine, you burn that transistor to get warm, okay? So to overcome that, power up the machine with 1 battery. So obviously it's all disconnected up to 2 batteries, apart from the terminal where the rock and roll. You stick the terminal onto the first battery. Let it power up, disconnect the terminal from the first battery over to the second battery, and you bypass that problem of the transistors heating up, and then you just leave it alone, okay? It's getting warm here. Right. Hopefully we'll get no issues tonight. Like a military plant operation, nothing ever goes according to plan, folks. Right. So, here we go. Like I said, we're manually going to be, you have to manually start these. So only for the first time. Now hang on, before I start this, people say to me, well once you've got the generator in the middle then, how are you going to start it? Well, that's easy, because This is only a little prototype, so that what I showed you on the floor, I can get my hand in and do it. Once you make it bigger, or the shaft longer, you want to just make it a little bit longer so you can still do it by hand at the top, okay? We overcome that, it's quite easy. Right, let's go. Where's the other? One, two, guys. So I'm going to put on the first. That's tapping. That's tapping. Right, where's it? That's it there. Yeah, so we're dropping power, okay? So let it power up. You do this on the first battery, on the 2-to-2 battery system, okay? Because you will blow your transistors because there's too much going in. So now that's powering up. I'm going to disconnect that. I'm going to put it straight on, and you will notice it will get powered more. Here we go. Problem solved. Right, okay. Primary battery. Charge battery. France. Alright. Pulse. It's still powering up. You can hear it still powering up. If you notice, I'm only running 4 transistors over the back there. I said you no less than 3. Okay, that is your lowest you can go on this machine is 3. Don't put 1 on. Don't be silly. You'll blow that transistor. 25, 22. And also, what I might do, because it is a live video, it's not coming off my storage from my phone, I'm gonna hook the light bulb up again, just to show you what's coming off the light bulb. Alright? Charge battery is stabilised, sorry, primary battery is stabilised at 24 to 43. Alright? It's still powering up, that might drop before it has to rise, it will rise. Okay? Charge battery, 25, 26. Alright? Don't forget what I said, these batteries are not identical. Don't do this. I'm experimenting, alright? You want identical batteries. End of, okay? Because I've been playing batteries for such a long time, I know what to look at in these battery chemicals with each battery, okay? So I've got one at 50 amp hours, I've got one at 74 amp hours, 50 amp hours and 90 amp hours. It's getting loud now, it's powering up. Now, do I want to touch that shaft? No, I don't. I've tried it in other videos. I'm not going to do it tonight on this video because it is dangerous and it will burn the skin off you. Do I want to touch the wheel with my finger? No, I don't. Okay, no, I don't. The idea is to be safe as possible. Alright? Now it's powering up. Got the bulb over there. I'm going to do all 3 tonight because it is a Facebook live feed. I'm going to do the capacitor. I'm going to do the light bulb. Alright? But it's powering up. Alright, I can put you back down to show you. You should be able to hear the electricity off of it. Alright, so, without touching that lock button, because I've done this on the tablet, it's a bit naughty. I touched the lock button before I went through the video, I didn't realise. I was still talking. Right, so this here is one of the crucial points. And this here is one of the crucial points. Alright? So, let's put it somewhere. Here. There you go. Right, now you're there, I'll go my tea. So there you go, peeps, alright? So, I've gave you the 4 basic transistors on the circuit. I would advise they are the ones you need to get. The best is NT56, you won't get them now. It's because of the euro, they're not delivered in the country, alright? They are made in America. They're not dear. It's dearer to get them delivered than it is to buy them, but they are great transistors. The second choice from the NT56 would be D2241, which is why I'm running this tonight. That is also a great transistor. Now, another little thing that I don't remember that now comes into my brain. If you're going to look for a transistor, what you want to look for is the dissipation. to run it, it should cost you 25 watts. So if you go onto NPN database on the transistor you're looking for, go right down the very bottom, it'll say power dissipation. It'll say 25 volts, 36 volts, 65 volts, 100 volts, watts, 25 watts, 65 watts, 100 watts. You want to get the lowest you can get it, right? At the same time, I will upload some pictures actually onto the Facebook to show you what you're looking at. This thing's running fast. So on the charge battery, 2544. Run battery is 2550. I'll show you. So the run battery, 2550. It's climbed. It will drop. On the charge, 2545. All right. I'm gonna put you back. So yeah, transistors. So the transistors were obviously NT56, DT441, C4495. Now it's a great transistor. You don't get much charge on the back end, but the shaft runs extremely fast to the point where it's been shaking. Alright, now there's no point in doing a video on that because I need to look after my health in here and talk to you guys who hold the camera. That's gone up 2451, 2547. Alright, so we'll let it do its thing. When you do start this, feel the tops of your transistors. Alright, just make sure they're not warming up. Alright, once you're confident they're not warming up, then you just leave them alone. Now I can leave this alone now and go indoors and watch film. I really want to. I've done it. Alright, ask the missus on her Facebook, she'll tell you straight. I live and die in the shed since I've been doing this. So the coils are not glued, like I said to you before. These coils are not glued together. They're literally on that coil winding machine. It's literally a stud bar that goes right through the middle, and then nut and bolted the other side. So that's secure on the shaft, and it's round. Alright, once it's round, before I take it out the stud bar, I duct tape it while it's on so I don't lose the coil. And I pull it off the stud bar and secure it even more. Mark, start and finish. Alright, remember that. If you're going to do this, you have to put a bit of tape on the finish and you know it's the finish side. 2452, 2551. Alright, showing that. So that goes for the run coils and the trigger coil. Alright? So the trigger coil and the run coils, if you're doing rectangle shape, they have to be all the same. If you're doing round circles, they have to be all the same. Don't do a trigger coil in this shape and then run coils in this shape. Alright, just keep it all the same, don't confuse it. Right, let's get you back to this. That's crazy, yeah. Right, run battery, 2452, 2552 on the charge. Alright. Now, a lot of people was asking about this. Okay, so the diode in this system is a 3 amp 1000 volt. You can use the basic diode now, which is 1 amp 1000 volt. The only reason why I went an extra higher one up, just in case I had problems with heat. I didn't expect I might have problems with heat, that's why I wanted to run up. Okay, I played about multiple ones. Like I said to you on the other videos, your capacitors have got to be the same. 450 volts on the charge, 450 volts on the primary, 15 faracons, whatever you class it as, 15, okay? So the charge and then quick, watch. Someone said to me about the capacitor, charging the capacitor, why didn't it go up to 400? It didn't go up to 400 because if you look, it's got 390 farads. It wants to discharge before it gets to 400, alright? If I was a little bit higher, I could have gone to 400. So I'm going to do this test tonight with the multimeter. I'll do a light bulb test as well, okay? Trying to remember, a couple of people were saying a few questions. Alternator, no go. DC motor, no go. Check keep the spacing. The trigger coil. Don't glue your trigger coil down, because your trigger coil, from the north magnet, because it fires on north, right? You want to be able to slide it left and right to get up the speed. So the only way you're going to work out the max and the start is basically just as the magnet starts to lose away from the copper and just as the magnet starts to lose away from the other side. You're going to mark your coil, okay? That's not difficult. Put it bang smack in the middle of the coil on north, carry on going until the magnet just goes past that coil. Either put it at start or finish, either way you want to do it. So I'm back on the camera. Same goes the other way. So I can slow this down, the charge quicker on the back end, but I can also speed it up to create more torque, alright? But when you do that, that's what I said to you in another video, if you muck about, this is, when I say you muck about at the front end, that trigger pulse is the front end. You start moving that back willingly, just look at the multimeter, see what it's doing, you start losing power very quick. So you've got to notch it very slowly, I mean literally, notch it, watch it. Notch it, watch it. Don't notch it, you can notch it back, forward, but you watch the volts drop like that. Gone, alright, because you're mucking about with it. 2453 on the primary, on the charge 2558. 2453, 2558 on the charge. Right, pull you back over it. Right, when you do this as well, when you start running it, you're going to smell a bit of burning. You go, right, what's going on? Checking the batteries, you start panicking, is there going to be a fire? Just relax. All you're going to be smelling is the run coils. They're warming up because they're charging on the back end. Now I said on a video that they run warm. They're above warm. Alright, remember the copper cola you buy can go up to 200 degrees. Alright, melting point. That's higher. That's how I know I've melted copper because I was fucking about putting 4 or 5 batteries on to see what I can get out of it. I was trying to push it, I was punching the ticket to see what I can get out of it. And you start burning and melting the copper. And what happens is when you melt the enamel off this, you create a fire. Right, okay. Right. Okay then, so let's shut it down. And all you do to shut it down is literally pull a terminal off. Die, take this out, take it out. Wait a minute. Now I can't touch this shaft. Let it die down a bit and then I'll be able to touch it to stop it a little quicker. Actually I can use my finger, which is not recommended. I should be able to tap it. You see what I'm saying? It's not perpetual motion. Because that was perpetual motion, I can stop that quite easily. I almost broke my finger. Alright, so let's put a screwdriver in there. Perpetual motion, you say? Like fuck. Should slow down by now, shouldn't it, Pete, today? That's sparking. Really bad. Use a different one. Still running. I'm saying, not perpetual motion. Basically, they've called it perpetual motion because, one, you have to manually start it up. That's how they get you. Secondly, if they can keep it perpetual motion, when you go to patent something like this, they won't entertain it because it's perpetual motion. Alright? Useful inventions at the hands of the people. Remember that. Right, that's stopped. I hope you all heard that because that was loud in my neck of the woods. Right, so we're going to now power up a light bulb. Let's try this pain in the arse, this light bulb. Right. I haven't got any other light bulbs. I've got the 50 volt. We could do the 50 volt if you want to, but this one, it's up to you. It's brighter, this one. Just to show you what you're up to. That's my meter turn off. Right. So disconnect that, disconnect that, disconnect that. Disconnect you. Push it back. Right. So positive into positive. I'll bring these over in a minute, Pete. Just give me a second. Actually, I'm going to bring them over now, so what I'm doing. Right. Yeah, positive into positive, negative into negative. Multimeter. do that. And do that. Right. I'm going to put you guys to see this. I noticed on the last test the light was that bright you couldn't really see the multimeter, so I've got to try and aim this, but because I can move about the camera tonight, we'll try it that way. Right, I'm going to power it up. Take it off there. Put it on there. Same again, because I'm running two batteries, power one battery up, let it power up, and then when you're confident it's powered up to a certain speed, hook it over to the second battery on the primary. Saves you burning out transistors. Now the second coil, the second circuit to this, right, you'll be running a two battery system. The only difference is one battery to another battery is on one transistor load, and another battery to another battery is on another transistor load. And then they're changed in series with one another. Yeah? So you'll have 4 coils, 1 trigger coil. You'll have, just as the trigger coil powers up on the north and powers one of the run coils on north, you'll have a coil next to that coil that'll be at south. So as soon as the first coil leaves north, it goes from north to south. So it goes from north, sorry, the power, and when that north magnet leaves that coil, the first coil north, it will go into the next coil, which will be north. So then obviously the coil before that will be south. So you're getting coils that are turning on, off, okay? Will bring up the speed a lot quicker than it is doing it this way, where they're connected on one panel of transistors. This is where we're going with this, okay? But I need you lot to do the first circuit and get an understanding how to build the device, how to go about it, because it takes a lot of effort. Then once you've got the concept of the one-to-one battery, that's why I said you do one-to-one battery, feel free to put more batteries on, but try not to do it because you burn out transistors. That's why I said just keep to the one-to-one battery. It won't be as quick as what I've got here. It's because it's only a one-to-one battery, but you get the concept of what you're dealing with, right? Then once I've got a lot of feedback through Facebook to do circuit number 2, then we'll go to circuit number 2, which is a lot easier than this circuit because you've built the foundations of the first circuit. Okay, that's where we're going with it, and then obviously the third circuit would be in the generator on top. Okay, I could have released a whole lot as a one-er, but you would have just been mind-boggled and gone, I ain't bothering with that, it's too much to do with. Alright, so you needed to build the foundations first on the machine itself, or the motor. Alright, so let's power this up. I'll bring the camera over to me in a minute while I want to power this up. Hang on, please. Hang on. I need this over here. I'll explain to you what I'm doing in a minute. Because that's only got 4 transistors on it, okay? That will just show you the difference in transistors, what you can run. Obviously I need more transistors to run this load. I'll explain to you in a minute why. Right, let's do this. Right, where's that? And then we're going to go straight from that, straight onto there. That should start flipping in a minute. That's the bulbing. 50 volts. Alright peeps, I'm going to kill it for a minute because I've got a dodgy connector. This is where all fun comes into it, okay? And I've got a dodgy connector. No. Ah, it was. See, that was lucky because that wasn't connected. Well, we'll find out whether it was or it wasn't. Because it wasn't connected, because you've got a 450 volt capacitor on it, what happens is the 400 volt capacitor will power up, will charge, and give you a quick, I say quick, it'll give you a little while before you work out why is that not powering up. If you had a 15 volt cap on it, it would bypass the 15 volt capacitor, blow and destroy your components. Alright, so it's vitally important you have a 450 volt capacitor. Alright, let's try this again. I might have kicked that bulb around in the shed a bit too much. I might have to put up the 50 volt one. Maybe. It's been kicked around in the shed a lot, I must admit, I'm not going to lie to you. That's charging the back end at 60. So look. It's charging, but the bulb's not lighting up, which means the bulb might be knackered. Alright, so let's disconnect it and put the 50 volt on. What a palaver. Disconnect you, put you on the positive. Disconnect you, stick the negative. Right. Turn down for about the Facebook Lives, isn't it, peeps? Alright, do this again. Aha! Right, so that's lit up, so that bulb's fucked. I've been kicked around the shed. I'll let this power up, and then I'll put 2 batteries onto it. That's lit up. You can't see that's lit up. You might be able to see it's lit up. I doubt it very much. What I'm going to do, I'm going to kill this side light. Oh, that's better, isn't it? Jesus Christ. Right, so that's powering up straight into the 2 battery system. Let it power up. So far, 15.5 volts. Right, here we go. Right, 17 volts, incandescent bulb lighting up. Right, it will get brighter. 24.46, it's dropping, it will come back up. Okay? It will come back up. It's got to power up before it can stabilise. 22.89, still powering. Alright. Can go for a long time. Alright, so what I will do, I'm going to stick fuse. I'll stick you there. Shit, it is. There we go. And it's not hot. Not hot at all, I can hold it forever. If 50 volt incandescent bulb, that'll burn you. And it's lit up well before the 50 volts. So it's 30 point, still climbing, 30 volts, 51, 31, 30, 30.9, 31 volts. Not hot. I can leave it there all day long. It's not hot. Alright? 1, 2, 3, 4, 5, 6, 7. It's not hot at all. Okay? Like I say, once we don't forget this is I'm going to sit down for a minute, peeps, because I think I'll punch in the ticket tonight. Let me get my vape. Right, so basically I took off the 4 transistors because I know full well through experimenting. Oh, what's going on? That's it. I know full well through experimenting, if you put a light bulb on, because there's no resistance, it gets confusing, alright? So those 4 transistors need that extra. I felt them warming up through the light, so that's why I pulled them off quickly to put on the system that 6 on, alright? But don't run this system no less than 3 transistors, alright? Right. So this is only the first motor that's this is the first one I'm gonna show you all, okay? We've got another device after this, and then we've got another device after that, okay? Remember, this is just to give you the concept that over unity motors do exist, regardless of what the experts tell you, okay? Now, anytime we have an earth wire, the earth wire, no one seems to question. I questioned the earth wire many moons ago, right? Why? Oh, by the way, lastly on that incandescent bulb, I said I'm going to let it run, see it blows. That's what I'm going to do tonight. We'll see if it blows, alright? So when you earth something, you're dumping excess power, alright? So that's what's actually happening with our circuits today, alright? Our electrical engineers, electricians earth everything because they can't control what comes in within the circuit. But they don't tell you that. Joseph Newman's motor was not earthed, it was off the ground on breeze blocks. It wasn't earthed at all, or whatever he put it on, okay? There was no earth. Because he knew full well, if you earthed it, whatever he was getting from the vacuum, it would die, it would get rid of it, okay? He wouldn't be able to do it. It's powering up fast now, peeps. So, let's turn you around without hitting the lock button. It's a 50 volt incandescent bulb, that's 42.9 and it's still climbing, alright? I'm just let it run. Run battery, 2444. I'll get up so you can see it, alright? Like I say, it makes no difference to a certain degree what transistors you use. You just want to try and find the best one. And in my opinion, NT56 and D2241, they are the best. Now, the one I put on tonight, that is, remember that is now? Oh, D2241. So basically, I've gone from 4 transistors to 6. Alright? Yeah, you have to, when you play, watch and wait till make sure they don't heat up. Okay? Now, I shouldn't be running 4, especially on a 24 volt system in and 24 volt system out. You can run a 4 transistors on a 1-to-1 battery system, not a 2-to-2 battery system. So I knew, so that's what I warned you about. Be careful. It can capture in the back end. You think, oh, what's going on? Nothing's running. Well, you know, you look behind your back, the transistors are smouldering. You think, that's it. Alright? So just be very mindful. So we're at 44.5 on the light bulb, and you're at 24.45 on the rung, the primary. It is getting loud in here now. But what I'm going to do, I'm going to step out of my shed, because I said to you, you can't really hear it outside my shed, so let's step out of my shed. I'm outside my shed. I can even still think. Can you hear it? My neighbours can't hear it. Let's step back into the shed. So it is a quiet machine. I've had this machine running late, 1 o'clock, half 1s, 2 o'clock in the morning. I think the radio was louder than the machine. Alright? So, still climbing. 45.1 incandescent bulb, 45.2, still climbing. Is it warm? Let's have a feel. Is it warm? No. Any 50 volt bulb, 100 volt bulb you've got in your house, you wouldn't be able to do this. Ask your kids to do this. They know full well not to, because they know it bloody hurts. That's not hot. Alright, not hot at all. Now, that locking the button. 45.3. 24.45 on the run, primary battery. There's your pulse. There's all your wires. Nothing's hidden. Alright. Now, notice I have round coils and rectangle magnets. Now, I was talking to I can't remember what I was talking to. So I was trying to explain why do we have to keep to the conventional square coils, round magnets, round coils. Now on the rectangles, we were going for the long straight lines down, so it triggers, alright, and it pulls. Now you can do that on round coils. Now on the round coils, so the half moons on the sides does the same thing. The only difference is on the round magnets, the flux of the round magnets is shaped that way, so you can use them. Now on the rectangles, it's a straight rectangle line, flux line, goes up and down, up and down. But I noticed it's quite responsive than the other way round, so that's why I've experimented. All right. Yes. So we've been running. Still 24, 45 on the front end. Oh. There we go, still climbing. 45.8, still running the incandescent bulb. Alright. Charge. 24, so it's primary. 24.45. Alright. We're going to get to the capacitor in a minute, that's going to be fun. Alright, so who else is watching here? Froggy's still here, Tony Davies, Billy, John Hammond. Great, seen John Hammond for years. How you doing, fella? Fred Springer, I've seen you for ages. Right, evening, Paul. Glad you're here, mate. So, yeah, so there you go. So, going back to Paul's question to me earlier about putting something on the shaft. Now, it is fast. I grant you it's fast. I've run a screwdriver to slow it down. I'd love to give it a go, as long as I can find a DC motor that's light enough to do it. It can't be, don't have no brushes in it. Because the brushes and the commutator inside the DC motor, there's friction there. You don't want no friction. So as I've explained to you with the bearings, I take all my grease out of my bearings. Anything I've ever done, I take the grease out. The grease is going to restrict me on what I'm doing, okay? Don't believe that you have to have grease in these bearings so they're going to implode, explode, fall apart. It's a load of nonsense, okay? In this system, it gets colder, alright? Now, I can feel... That's cold. That's not even warm. I haven't even got heat down here, but that's cold, alright? I know it's cold because my fingers on the metal is freezing, like the shaft. The shaft is even cold, alright? So, like I say, you know, I'm open for discussions. If we want to do it, if you want to give it a go, see if it fails or see if it succeeds, I don't know. We'll give it a go, but that's not why I want this. Okay, I want this to power itself in the load so I can run magnets on the centre shaft so it can then power through a three-phase upright generator. So I was trying to explain to you, because everyone knows about wind turbines and how they act. Magnet at the bottom, magnet at the top. Opposite poles from each other, and they create a bouncing effect, and obviously I say electricity is generated, right? No different what's going to happen here. You can go some powerful magnets, okay? Where the hell's my TV? Yeah, so what are you looking at? It's fucked up. 24.45 still. And on the back end, 46. Oh, that's it. That's it. 46. There's 46. Still climbing. And the bulb is the bulb. It's still the bulb again. Oh, not really. I say it might be a little bit lukewarm, but not hot. All right. All right. Let's bring it back round. So what we do now? I'll kill the motor and we'll stick in the capacitor. Oh my days. I'm hoping, have I measured how fast it's going? Unfortunately not, Paul. I've actually ordered a tachometer, or whatever they're called. I've ordered them one level off of eBay, alright? Just got it, how long been running? So, I don't know the time on this. Well, I first done the two battery systems. We run them for a little while. I've only just hooked this bulb up, so I've only been disconnected no more than say 4 minutes, not even that. So we're still sitting at 24.45. Charges there on the back end is 46. So it's not 46 volts that's in that bulb. That bulb's 50 volts. So you've got 50 volt bulb plus on the outside of that bulb is 46. So what's that? 90, 50, 60, 70, 80, 90, 96 volts on the back end. Alright? But in a way, it's good that that LED bulb didn't work because obviously that's bright and you can't really see the multimeter. Alright? So, right, so that's the full power on 3 coils. Alright? Just 3 coils. Now, I did show you earlier why Paul's only disjointers. So, was trying to explain, Paul, about petrol motion. This is not a perpetual motion, even though you have to hand wind at the beginning. I'll explain to you why it's not perpetual motion, because if this was perpetual motion, I shouldn't be able to do what I'm about to do. Let's hope this, bring it back. Ready? Alright, I can't touch that, there's no way on this earth. Now, I just 24, 44, because I put a bit of pressure on it. You watch that rise back up. Dropped on the back end. Alright? That was with a lot of power. That's how I know if I was to put a DC motor on this, I can't see it working. But if you was to do it with magnets, it's already rising. Hold up. 42.8. Alright, 42.9, so it's already rebalancing itself. That will rise, that will come back up again in a minute, I'll show you in a minute. So, you've got to find something that's actually fluid and no restrictions for the DC motor, or AC motor, whatever you want to call it. It's actually not AC, it's DC. But, if I was to turn the motor to the side, you've got to be able to have a DC motor that's gonna, hi babes, you've got to be able to have a motor that's got no restrictions for it. So if you're gonna have a DC motor, you're gonna have to strip out all the bearings, take all the grease out, they have no brushes in it, alright? But I do know you can do exactly what I'm doing to this motor here on a DC motor, alright? I will leak that one very, very soon. Basically, the DC motor has one windings in it, to the commutator and back on to the commutator. Now you can actually strip out the whole complete lot, rewire it, and put another commutator at the bottom. So what you power in, you get back out on the back end. No different than this, we do it for a DC motor, alright? Who's doing it online? We've got his name. I'll have to share his link. I was flabbergasted what he was doing. So he was powering the motor for a DC motor for a battery. He was powering it, but rather it do work, so basically what he put in, he got back out, because he's got two windings within the DC motor. Alright, so let's try and explain this actually while you're on the camera. So basically, on this is a treadmill motor. So what he's done, forget that it's got brushes in it, right, so forget that for a minute. Actually, don't forget that, that's what we're talking about. So the brushes down here, he had the same system up here. So what he's done, he powered it here, and got the back end, got the same energy back out this side. It's very confusing, people understand that. They're not being made like that. So this is the same system, same principle what he was doing, I'm doing here, alright? The only difference is, you can't, they're all coming back to me now. Okay, now. Someone said to me, can you just take the two terminals then, just put them back over to... No, because that's you killing the dipole, you're killing the power source. And then like everyone's saying, what's a dipole? Like, now, it's a battery. It's a battery source, right? Now, we're splitting the negative and positive charge. Right, that hasn't come back up. So, just for you, Paul, we had disturbed it with a lot of false 2444. It was at 2445 before I put the screwdriver on, alright? 44, 47, alright? So that's how I know it might not work, if I'm honest with you. But we're going to use the shaft as we're going to literally stick magnets on this shaft. So if we're going to do anything, we're going to stick them on the block, stick the block on the shaft, secure it on the shaft with your north and south magnets away, very powerful magnets mind you, with, oh yeah, Paul wasn't here. So Paul. So basically this is a baby, it's incomplete because I've been taking the copper off of it. This is a three-phase winding, and this one will go in the middle of the shaft. And obviously down the centre will be the 12mm shaft, and with that 12mm shaft will be magnets north to south. But obviously this does charge, I've done it, okay? You want a thinner wire, you want the high voltage. At the same time you still want some current, so there's a balance between the coil you need to get, alright? But that will sit in the centre. So we're doing the same principles you do with a wind turbine. The only difference is it's an upright three-phase generator, not a pancake, alright? That's the only difference here, alright? That's why I try and explain to people, I don't want to put this shaft to a DC motor and power for a DC motor, alright? I'm going to try and make this as simple as possible. You put too much stress on the motor to try and get the DC motor to run. We all know the conventional DC motors, everything else have been wired up wrong anyway, okay? But I'll go into that later on down the line. But I'm trying to get the bare basics out to show people that the over-unit motor does exist, okay? That's why I said to you about doing the one-to-one battery system. Get the basics out of the way. Obviously, circuit number 2 attaches to this.
So what I'm trying to do is get you to build the foundations of what I've got on the floor here. This is not hard, okay? Like Paul said, some of it is quite, you've really got to source it. I'm not going to deny that. The Perspex is expensive if you go and buy a 1 inch thick Perspex. But we want to use the floating shaft in the centre and its RPM to power in out. Like I said, Joseph Newman knows full well, if you pass a magnet over this, the atoms precess at right angles. Alright, so all the atoms in this coil are all mixing back, so like magnet just loads dotted on a bit of paper. As soon as you pass a magnet past that, they all align and shoot. Atoms precess at right angles. Bosh. Alright? So that's what we're looking at here. It works, I've done it. Okay? So that's that. So 45, 43, that's still. Let's move it. Let's move it. 24, 44, still ain't moved. Still running. 45.4 with the bowl. Alright? But don't forget, like I've explained in other videos, I'm wasting power doing this. Okay? I can do this 20 hours. This will run 20 hours like that. Let's leave it go. Ask the missus, she's on live with me now. She's seen this thing run all day while the kids play in the garden. I'm back and forth, back and forth, back and forth. Paranoid, in case something might have gone wrong. Kids at the shed, don't go in the shed, don't want you in the shed, because the magnets might fly off, or they might decide to touch something. This is why I said to you, I was a little bit paranoid of releasing this circuit, because if you kids have accidents, that's on me. That's what I was trying to explain, that's on me, alright? But, you know, if you're going to do this, if you want to go and make a cup of tea, get your wife, your girlfriend, or your mum and dad, or your mate to look after you while you go do that. Or if you've got it in a place like this, close the door behind you, because accidents will happen. And I know that because I've got 3 boys, so this is what I'm saying to you. You have to be very careful around this. Even though this is a baby toy, now this is only a toy. This is a learning toy. This will be upscaled very easily. Right? I did say that the dimensions will change, but that's not much working out. Okay. But this is just a toy to show the concept. It does work, alright? So, like I say, Paul, who's on here now, you know, we were talking earlier, it is possible, we can do this, okay? I'm up for any suggestions if you think, oh, try this then. I'll try it. So I'm up for checking out most things, alright? But don't forget, this is the first device that I've gone live on after other ones. Now I asked my wife, who's on live feed, we will use, looks like there's a load of power in that motor considering the power you're using to run it. Yeah, that's right, yeah. There's a lot of power in that motor, a lot. You can even need electricity within the wheel. If you get closer, you can need it. So there's a lot of power there, okay? But like I say, we can try it. If we're going to do it with a DC motor, we're going to have to strip all the bearings out, so it's literally no restrictions at all. The only restrictions you may get will be from the brushes, alright, on the commutator. But like I say, I had a baby version of Joseph Newman motor. My wife's sitting in the kitchen, it fucking ran quick. Alright, so I really want to get that one up and going and showing you. I really want to show you the fact that I want to let you see the plasma arc, which is the electrical gas in the atmosphere and the contacts of the on and off manual commutator. Alright? So the Joseph Newman motor is not difficult to make, alright? That's why I was trying to urge people to look him up, because one thing is a bit of a crackpot. But if he was allowed to pattern his device, you would have what I think you've got now, do way better, alright? But yeah, let's disconnect. We've been running for a while. So, here we go. So, I don't know what time you got here, Paul, but I'm about to disconnect it. We was running, I don't know how long we've been running for. It doesn't say on my tablet. But, it's at 24:43. So we've dropped down 1 pole since you've probably been here. Actually, we've dropped down 2 because I disturbed it with the screwdriver. But that's a lot of power. Power going on the back end, 45.6 with the bowl. Alright, now, what I'm going to do, I'm going to stick these here, and I'm going to disconnect it. Just before you do disconnect anything, always check the transistors, just to make sure they're not hot. Now the block's warm, and as it's doing its job, Paul, you weren't here, you come in late. Obviously Paul's he's already looking this stuff up for years like I have. These are LED blocks. Pull down your transistors, alright, Paul knows that. So, disconnecting, the light instantly goes out. I'm going to let that wind down. I'm going to do, actually, right, so, let that wind down, so I can get a chance to read the comments what you're thinking. Right, let's have a look. Yeah, so yeah, Paul, there is a lot of power in that flywheel, alright? You can get any flywheel you like. I forgot to say earlier, what you want to try and do, you want to try and get a flywheel and a magnet. So now, Paul, you sent me a message about the corresponding of the north and south. So the gap between magnet to magnet is 1.5 inches. And it has to really, so I've got 16 magnets on that, so that's why my coils are slightly off. You really want to get them at 9 o'clock and 3 o'clock, or 3 o'clock for your end and 9 o'clock your end, you see it? Alright, so 3 o'clock and 9 o'clock. You want them straight lines, because you want to push and pull at equal balance on the wheel. But because my wheel is not the correct size, you want to call that, I have to have a coil just off a 9 or just off a 3, either way you look at it, right? It still does the same thing. You don't have to have 9 and 3. If you really wanted to, you could have 11 o'clock and 1 o'clock on the 2 coils. As long as they're pushing and pulling, that makes no difference. It'd be off balance. I haven't tried it, I can imagine it'd be off balance. So you really want them equal of the wheel, yeah? So that's why I said 9 and 3. That's slightly off. So the south pole is the one on the primary battery side, and the north pole is on the charge end side. Okay, so yeah, that's that. So let that wind down, and then we'll do the capacitor. We're doing all 3 tests all in one on the live feed. I should have done live feed at the beginning. But yeah, this is what my wife bought me for one Christmas. I was quite impressed. I was after this for a long time, because for me to understand the atoms within the coil, I had to play with this, because when you power this up and you hold it and you move it like Joseph Newman was doing, it shows you, and if you run it up and down, it doesn't move. That's how atoms move. If you move it at right angles, it does something in your hand. You can't explain it, but it's the momentum force within the wheel within this toy. Yeah, so this is basically a gyroscope, so all atoms behave like gyroscopes. Okay, that's how I know. Let's forget about the idea about putting the DC motor on this, because I'm trying to get people's concept away from that. Let's get away from that, because there's better ways to do this. Alright? So let that wind down, and then what I'll do, I'm going to stick fuse out the way over here. Right. I hate these things. I hate them. Right. See that I tried running this bulb, Paul. Don't know if you come in late. Obviously, I've kicked it around the shed left, right, and centre, so it went in my way. So obviously, it didn't work. But that's what I was trying to explain. You need a 450 volt cap on the front end and the back end of this. Okay? Because if something goes wrong, like it was lucky it's a live feed. You can't prep for that because it's a live feed. But powered it up from the primary, this bulb wasn't lighting. But I could see the multimeter firing up 60 volts, 70 volts. You've got a window of 450 volt. Alright? We'll say 400. To be on the safe side. That gives you enough time to work out something's not quite right. Yeah? I checked the bulb, I checked the connectors, I disconnected it, restarted it, so that saved all my components on that end. But if you had a capacitor that was 15 volt, say 15 faricons, whatever they're fucking called, yeah, it would have blown that bulb and blown all my components, and it would have been game over the night. Like, let's go indoors, have to order some more parts. Buy the big 450 volt caps, 15 faricons, whatever they're fucking called. I hate that word. Right. Capacitor. So negative to negative. What you want to do with this capacitor is you do not want to touch these terminals together. So try and separate them away from each other the best you can. But like I say, you can. Someone asked me, because he loves running, he's got an idea of running capacitors to big banks and things like that. Personally, you can do that on this machine. You can power up the machine and just have big capacitors and store the energy, but you won't want to discharge that. You won't want to discharge that back to the primary battery. So this is why this is a battery charger. So not only is it a battery charger, it's a battery conditioner. Not only is it a battery conditioner, it's a motor generator. Now I didn't say that in one of my videos because I was trying to. When you say motor generator, people get excited. Go, wow, let's get the motor out of the way. I didn't want to. So yes, it is a motor generator. Yes, it's a battery charger. Yes, it's a battery conditioner. Yes, it's a motor. All right, but it's a toy. Okay, so you know this is just a toy. Right, power you up. Power you up. Put Uzi up. Then power back up again. Yeah, that's powering up. Straight into the second battery. Push D. Right. Here we go, peeps. Capacitor. Just yeah, let it power up. So here we go. Primary battery, 24, 43, 42. That'll come down. It'll go back up. We'll come back to that in a minute. 100 volts. Let's come back to that in a minute. Just want to quickly check my transistors. So you still have to check your transistors because you don't want to have no mistakes. Yeah, they're alright. We're looking over there. 123 volts. Primary battery's dropped. (24, 36). 135 volts. You can't say that. I'll show you in a minute. 24, 36. So here we go, just quickly. 24, 36. You're going to disturb the front end. 150 on that capacitor. It's still rising. I've got to discharge this yet. It's going to be fun. Alright. 24, 36. Like I say, every time you discharge, every time you turn this off and restart it, you do lose a bit. That's why I said in one of the videos, it's coming back up to power now. 24, 37 is powering up. 163, we're still recording yet. 165 volts. (24:37). There's your pulse. 172. That's fast, that wheel's moving. Right, turn it around. Right, okay. So set north and south and measure between to calculate equal measurements for the rest of the magnets. Yes, that's correct, Paul. Yeah, I used to use big capacity on car sound systems to protect the car systems. That's right, yeah. So the 450 volt at the front end, what you want to do, that smooths out the operating load going in, yeah? So I see where you're coming from, Paul, yeah. So, yeah, I agree with you. So 24:38, so the primary battery's rising. 24:38. There we go, it's rising. It's flipping 37 to 38. 192 volts on the capacitor, 93, still rising. Alright, turn it back. A bit else, see more. Been a bit of a couple of times for that. Yeah, they're all, weren't they? When I first got bitten by one, cool mate! No, you don't get bit one in. That's why I was trying to explain to people, don't go out and buy these big capacitors, like these 400 volt, I know, fans with Farrakhan's. You don't want that. You don't want to discharge them. Trust me. You don't want to put a screwdriver over that and discharge that. That's a bad day out. And Paul knows where I'm coming from with that. So yeah, that's it. So we'll run this. So that's gone up now. So 24:38. So you know it's still rising. Okay. There's your pulse. There's your pulse. The interesting thing about this, hang on. The interesting thing about it is 205.3 still rising. Right. The interesting thing about this is when I put my hand near this motor, it's cold. Can't really show you, but you might be able to see. Put my hand in, don't touch the wheel, but it is cold. That's obviously the momentum from the wheel moving the air. It's cold on top, cold round. The only time it gets warm is when it's near these coils, because they're charging the back end. 210 volts on the capacitor, 24.38 on the primary. The transistors and the film transistors, they're running cool. I was panicking at the beginning because when I went over there, I went a bit quiet. I was waiting for one to blow, because obviously we're all running a two system in and a two system out. Well, the two system out is actually the capacitor. If you have to put it on one battery, power it up, bring it up to speed. You don't want to put 24 volts straight in because you'll blow transistors. So you want to put it on one battery, let it power up for a little while, disconnect that one battery straight onto the second battery. You'd have obviously a cable between the two, so in series, alright? And then obviously bring it up. If you do it too quick, you will burn the transistors. That's why I was trying to get people just to do the one-to-one battery system. 217.5, 17.8 volts on the capacitor, 24.38 on the primary. There you go. 24.38. By now, peeps, by now, I should have run out of power. I should have run out of power on the battery system when I was charging the batteries. I should have run out of power charging the incandescent bulb, and I definitely should have run out of power doing this. 220 volts on the capacitor. Alright? I've still got 24.38 volts in them batteries. Alright? Now don't forget, on some of the videos, my cut-off is down to 20. I don't really want to get down to 20 volts. So how long will it take me to lose the 4.38 volts? A fucking long time. Ask the missus, she's watching, alright? I live in this shed, so I'm experimenting. That's why I needed to get it out. But I was a little bit concerned about certain people building it in case accidents happen, because it comes back on me. Alright, I know I'll have a guilt conscience. So 224.3, so let it run. Whew. I've got to discharge that yet. Babe, you got life insurance? I hope you have. I know it's not funny, I'm just one anyway. Right, so nothing's moving. 225.7.8, 226. Right, folks. There's your capacitor. There's your voltage. 24.38 still. There's your pulse. Stick you on it. It's loud, isn't it? That is fucking loud. Alright, I'm going to stick you here because I'm about to get ready to just get rid of this in a minute. 230 volts. Sorry, 229.3.4. See, when I first ran this machine, I was in there drinking a cup of tea, I was reading on the tablet, powered it up for the first time, and the capacitor went bang! And that's scary. If that happens to you, just step out the shed, because some of the capacitors, what they blow out the back end, can be a bit toxic, okay? Not all of them, some of them. And I don't want this going on me, so I've got to look at this voltmeter, and there's a cut-off that I know is a cut-off. This is what gets me. A normal motor would run out of battery down by now. Definitely, Paul, 100%. Do you think the caps in the flywheel helps keep it cool? Yes, 100%. That's unreal, the speed of it. Mate, I'll invite anyone who wants to come round. Anyone. You want to come round and witness this? You can come round. 232 volts. 233 volts in that cap. 24.38 still on the back end, outside the front end. Paul knows full well I should have had, my power should have been gone by now. 233 volts, 0.7, 0.8, we're still climbing, peeps. Alright, there's your motor. Now, just for Paul, because obviously it was Paul that wanted to know, I'll try this before that cap blows in there. I don't want that cap blowing on me. If it slows down, I'll have to entertain that first. 234, right. This is, and I like doing this. I'll take everything off. That's the last thing I want, is that climbing around that shaft. I'm going to try it, Paul. Watch. Yeah, I can't grab that pole. Not a chance on earth. I'll end up in Basel Hospital. Right, 235.6 volt on the back end on the capacitor. On the front end, 24.38 still running the same speed. 236.1. It's still here, it's still here. I'm back. Right. You still with me? Right, stick it there. Right, okay. I only want to use to say something, so I know it's still running properly. We're at 237.6 volts on the capacitor. Right, now we pay for the switch price, Paul. 24.37. It's been running all this time, it's dropped down 1 decibel off the clock. 238.2 volts on the capacitor. Video's a bit glitchy. Sorry, Paul. I must have lost Wi-Fi from down the shed. Did it glitch out a lot? Right, okay. What I'm going to do, I'm going to leave this here and I won't touch her now. Alright. It should be right. It's because I'm moving the tablet about, that's why it's glitching out a little bit, so I'll leave it where it is now. Right, so we've dropped down we've dropped down off the clock on the charge on the charge end, the power end, front end, right? It's at 24.37 volts and we've dropped 1 off the clock. But all that time we've been running since you've been here, Paul. Alright? The voltage on the cap is at 239.9 volts, 240 volts. Alright, power's still the same. Actually, I wonder if. No, they really are, because it's too much over. One more power. Load of power, right, okay. Right, okay. We're going to discharge this in a minute, discharge this capacitor in a minute. Still at 24.37 volts, 240.8 volts on the cap. Alright? Right, you're listening, I've got to find something that's earth. That'll do just fine. So when you discharge this capacitor, it's cool to tell you, don't use any old screwdriver, you have something that's got a bit of protection on his hands. Alright? Because if it arcs through to you, that'll hurt. So this here is solid plastic and a screwdriver. This here is a screwdriver with rubber handle. Which one would you use to discharge the capacitor? It ain't that one, I can assure you. So this is why, when I release this circuit and people start mucking about, you can hurt yourself. So as long as you've got a bit of common sense, rubber stops you arcing through the air. That's why we wear rubber boots and things like that in the workplace, especially if you're doing multiple other things, like oil and everything else. Rubber handle to discharge these capacitors. To 24.37 still, it just dropped down to 36, it's got back up to 37. Right? So you can't determine the switch price. Some will fluctuate with others. Some will go 5 minutes, some will go 25 minutes, some will go wherever long it goes. Right? You can't determine that. Right, let's just check the heat of our transistors. Cold. Running cold. Alright? Yeah, the run coils are very warm. Alright? They're not excessively warm, but again, what we're saying here. Try to understand why the caps are in the system. Is it a kind of blowout security? Yes, it's a blowout security. So if you've got if your back end charge, if your back end charge is not running correctly, say you've got a battery that's not charging, what you do, the capacitor will build up and then blow. It will stop the electrical part, all your components blowing out. Same on the primary end. If you power in and there's a problem with any of the wires or the capacitor itself, or whatever the case may be, that does exactly the same thing. There's security systems in place for that, alright? But they play other functions, like they smooth out the motor, they smooth out the electrical, the back end. It also smooths that out. Okay? If you didn't have the capacity straight through a diode, it'd be uncontrollable. It wouldn't be smooth enough to power into a battery, alright? So that's why they're there. But the main reason why they're there is their safety devices within the system, alright? What was you say there, Paul? I've got a bit of research to do. I normally repair electrics. This is out of the ordinary, that's for sure. Yeah, that's for sure. 100%. Right, 243.9 on the cat, and on the primary end we've got 24.36, so we've dropped down, Paul, as you've been here, 2. Do 2 decimals off the clock, for however long we've been running for. Alright, I've still got, theoretically, 4.36 volts to play with, and that will last a hell of a long time. 244.2 on the volts on the cat. What I'm going to do now, oh, I've got 10% battery. Right, what I'm going to do, I'm going to kill this now. Before I kill it, I'm going to show you the end results. 24.36, 244 on the cap. I'm going to stick you back up there so I don't want you glitching out on me. I've got 10% on the battery, so I've got to be quick now. Disconnect the pulse motor. That's now disconnected. Anyone knows, you don't want to, this is now live, this capacitor. You do not want to muck about with this. Right. This is live. We're going to discharge it. What's going on? Woof! Right? That's how serious that shit is. Alright? It scared the shit out of me. There's still be more in there. There you go, it's still cracking. That's now discharged. And with these, you want to discharge and you want to clip them back in together because they've got a tendency to self-charge themselves, re-engage, okay, because they are a capacitor. You want to loop them back on themselves, and there you go. What I'm going to do, yes. So there you go. Any questions? Even out surgery as well as our guest. Even out surgeries as well as. Yes, that's right, Paul. Yes. Okay, right. So that's powering down. Well, I've got 10% on my battery, which was absolutely full before I started to come out here. So there you go, peeps. It has been a pleasure. Whew. It's been hard work, I'll give you that. You've got to do all 3 systems in one go. If anyone wants to come around here, the likes of Paul's, who's obviously got his own thing going on, feel free to come round. I'm only in South Rockington. I'm still researching myself, I'm still tinkering around, I'm still doing other devices, and God knows what else. Okay, it does take money, it does take time. Like I say, I'm glad people took a keen interest, okay? There's still lots more into this, okay? There's still a lot more that can be done to this. This is just the bare basics, but obviously we can charge batteries, we can charge light bulbs, and we can charge capacitors, okay? But yeah, they're not nice, them capacitors, so I'm glad Paul knows what he's all about with the old capacitors. They scare the shit out of me, but I have been bitten a few times, especially on car batteries, which is, it still runs up you, still hurts you, but it's a shock when it first initially does it, alright? So, yes, thank you very much for joining my live tonight. I hope people are still building, or if you've got any questions, just ring me, text me, Facebook me, leave a comment, whatever the case may be, okay? If you've got any datas out there, do the same thing. I feel free, come round, okay? Just come round. Nice demo. I've got a workshop now, so we'll no doubt start collecting bits for this. Look forward to find out more about yeah, no worries, Paul, no worries. Thank you very much for joining tonight. I know a lot of people were sceptical about it, but like I say, it is possible. I've shown it can be done. Like I say, it's this only little toy, it can be upscaled, alright? Anyway, I'm going to love and leave you, because it is getting late, and I'll see you all about. Any problems, call me, inbox me, text me, whatever the case may be. But have a good evening, stay safe, I'll see you all later.